I put together a sketch using Millis. Here we have an array of LEDs that turn on and off in sequence, and one which has a delay of 3 seconds, and also we have one here activated by a push button. And I've also used a servo being actuated by this potentiometer. This part of the sketch only outputs a statement every second. For this, I have made a sketch to output the word bingo every second. We must use unsigned long because the Millis value goes up to 4 billion void loop. Every second, it outputs the word bingo. Afterwards, we update the previous time to the current time. For the blinky sketch, we've set it to execute after 3 seconds. We've declared two variables. The LED 13 corresponds to pin 13 on the Arduino Nano, and an LED state variable which initially we set to high. We set LED 13 as an output, and then in the void loop, after every 3 seconds, it will check if the LED state is low and switch to the LED state to high, and if it's high, it will switch it to low. Then we will write it to pin 13 and then keep track of the current time. For triggering a button, I've declared two variables. I've used pin 4 as a button pin and the red LED on pin 2 as an output. In the setup, we have declared the button as an input. So I've used input pull up so as not to require an additional 10 kilo ohm pull up resistor and 5 volts. Using input pull up uses the internal 5 volts of the pin on the Arduino Nano clone. And we've declared the red LED as an output. So in the loop, we have a button state that we read from the button on pin 4, and then if the button state is low, we write to the red LED pin to high. Else if the button state detected is high, we write to the red LED low. It will do this for an interval of half a second, but you can change this to whatever interval you like. Let me change that. In the sketch, I have created an array for the 6 LED pins 7 to 12 on the Arduino Nano clone. It's okay to leave this empty. The compiler will automatically assign those values when needed. Then we go on to the setup. I've declared those pins as an output using a for loop. In the void loop, we're incrementing the LED pins using a byte J, which initially is indicating at index 0, and while it's less than 6, we increment J. So it will increment the index from 0 to 5, and then we write the LED pins to high for each and every one of those pins, and then after a short delay, which is 100 milliseconds, we decrement the LED pins to low. For the servo control, I've included the servo library, servo.h, declared an instance, my servo, and two variables, pot pin equal to A0 on the Arduino Nano clone, and a variable val that will be used to actuate the servo. So on the setup, I've attached pin 3 for the servo, initiated communication, and on the loop, we read from the pot pin, which is A0, we put it in the variable val, and then we map that value from 0 to 23 to 0 to 180, and then we write that value to the servo.